the fabrication and fusion of steel, iron, and other metals into products for commerce, transportation, and construction. Advanced welding skills hold together our modern industrial society. In this volume of our series, we will examine oxyfuel welding systems, their design and basic operation. Throughout this program, important safety information will be highlighted. Safety first means stop and think safety before you undertake the next welding procedure. It's also important to always develop your welding skills under the watchful eye of an experienced teacher. There is no substitute for hands-on training. To prepare for oxyfuel welding, a student should have the correct protective clothing. Pants and shirts should be flame resistant. The pockets should be covered to keep sparks from entering, and the pants should not have cuffs. A cap will protect your hair, and leather gloves are essential. They can be tight-fitting for light-duty welding and cutting. In addition, welding goggles with protective filters are essential. Goggles with flip-up lenses or stationary lenses should fit over safety glasses. Filters are rated from number 1 to number 14. A number 4 to number 6 filter is suggested for oxyfuel welding. It's also always a good idea to wear hard-toe safety shoes when welding. Safety first. Never work around welding equipment when carrying matches or a butane lighter. They are flammable and should be stored away from the area. Acetylene is a type of gas which, when combined with oxygen, produces a hot flame of approximately 5,600 degrees Fahrenheit. Natural gas, butane, and propane are other types of fuel gases. They are generally used for soldering and brazing. Acetylene is stored in seamless cylinders under relatively low pressure, approximately 225 pounds per square inch. Acetylene is dangerous and unstable above the working pressure of 15 pounds per square inch. A safety cap protects the cylinder valve from damage during transportation. The cylinder valve is controlled with a hand wheel or a cylinder wrench. Safety first. The hand wheel or valve wrench should always be on the cylinder valve when in use. This allows for quick shutdown in case of emergency. Oxygen is stored in seamless cylinders under high pressure, approximately 2,200 pounds per square inch. A safety cap is also used on an oxygen cylinder to protect the valve. Oxygen and acetylene cylinders should always be stored in an upright position. Whenever the safety cap is removed from a cylinder, it must be chained to an oxyfuel cart or other solid mounting. In an oxyfuel outfit, fuel gas and oxygen are supplied from the cylinders through pressure regulators. The pressure regulator reduces and controls the pressure from the cylinder. Regulators typically have gauges for both the cylinder and working pressures. Markings in red indicate pressure above 15 pounds per square inch on the acetylene working pressure gauge. Flexible rubber hoses connect the regulators to the welding torch. The oxygen hose is green, the fuel gas hose is red. Oxygen fittings have right-hand threads and acetylene fittings are left-handed. Oxygen fittings are always plain and acetylene fittings are notched to prevent a mix-up. A flashback arrestor prevents fire from entering the hoses or regulator, resulting in an explosion. A check valve keeps gases from flowing back from the torch into the hoses or regulator. They can be installed between the torch and the hoses, or between the hoses and the regulator, or in both places for extra safety. Safety first. A flashback occurs when a backfire forces burning gases back into the torch. Never use a torch without a properly installed check valve or preferably a flashback arrestor. The oxyfuel welding torch is the business end of the outfit. It controls and mixes the fuel gas and oxygen. Controls for both gases should be clearly marked. The torch tip contains an orifice which must be sized correctly for the job. Torch tips should be cleaned regularly. They should not contain dirt, filler metal, or weld metal. Ignition of a torch is usually made with an igniter, such as this flint and steel spark lighter. Never use another torch, matches, or a butane-type lighter to ignite a torch. Always warn others around you that you are lighting your torch. Setting up to weld with an oxyfuel welding outfit should be done methodically and in a given order. First, make a visual inspection of the cylinders, hoses, regulators, and torch. Check for damage and proper assembly. Soapy water or leak-detecting solution should be used on the fittings if necessary. Make sure that both regulators are closed before opening the cylinder valves. A pressure regulator is closed when the pressure adjusting screw is backed completely off. Turn it counterclockwise until it feels loose. Slowly open the fuel cylinder valve about 1 1/2 turns. Make sure the hand wheel or valve wrench is in place for quick shutdown. Then, slowly open the oxygen cylinder valve. You should backseat the oxygen valve by opening it all the way. Now adjust the fuel working pressure. Hold the torch firmly by the body, never by the hose connections or valves. Turn the acetylene torch valve 1 complete turn open. Adjust the acetylene regulator screw clockwise to the correct working pressure. This will depend on the size tip you are using. Check the manufacturer's recommendation. Then close the acetylene torch valve. Now, set the oxygen working pressure. Open the oxygen torch valve 1 full turn. Turn the oxygen regulator adjusting screw clockwise to the desired working pressure. Then close the torch oxygen valve. Now check both regulators for leaks. Open and then close both torch valves. The acetylene and low-pressure oxygen gauges should remain constant. If the pressure continues to rise in either gauge, a leaky regulator or hose is indicated and it must be repaired. Opening and closing the torch valves also purges the system in preparation for ignition. If you have followed the previous steps carefully, you are ready to ignite your torch. First, open the fuel torch valve very slightly, approximately 1/16 of a turn. Use a spark lighter to ignite the fuel. Open the torch valve a little more until the flame becomes rough, about 1 inch in length. Then close the valve until the flame is not smoky. Slowly open the torch oxygen valve and adjust the flow until you obtain a neutral flame. A neutral flame is a dense blue flame in which the fuel and oxygen are properly adjusted. It is characterized by a bullet-shaped inner cone. The cone is rounded on the end and the torch does not hiss or sputter. It's also important to know how to shut down the outfit properly. First, turn off the oxygen by closing the oxygen torch valve. Then turn off the acetylene by closing the torch acetylene valve. Then completely close the cylinder valves on both cylinders. Oxygen first, then fuel. Making sure no source of ignition is nearby, completely open both torch valves. This allows all the gases in the hoses and system to escape. Check your pressure gauges. After they return to 0, turn the adjusting screws on the regulators counterclockwise until they feel loose. If you are not going to use the outfit again, such as at the end of the day, always close the cylinder valves. Make sure the outfit is stored away from hazards and in a vertical position. Safety first. Never set down a burning torch or leave it unattended. A serious fire hazard exists whenever a torch is lit. In modern industry, most welding is accomplished with an arc welding system. It is still good to know how to weld with an oxyfuel outfit. Many of the basic skills are the same. The torch can be held in one of 2 ways. A lightweight torch is usually held like a pencil. A heavier torch is usually held overhand like a hammer. Use whatever position is most comfortable for the job you are undertaking. There are 2 methods to direct the flame to the work area. In the forehand method, the flame points in the direction of travel. In the backhand method, the flame and torch are pointed away from the direction of travel. In both cases, the object is to concentrate heat to create a good weld pool. Good penetration of the base metal must be achieved in all welding processes. The width of the weld pool indicates the depth of penetration. Thicker metals require a wider weld pool. When carrying a weld pool, you are concentrating heat along the work. It is not necessary to use a welding rod to carry a weld pool. A clean weld is an indication of complete penetration and fusion of the base metal. Edge joints and corner joints can be welded without the use of filler material. Other joints require the use of a filler rod. Filler material is added to all types of welds through the use of a welding rod. They come in a wide variety of types and sizes. As the rod is oxidized, it adds material and strength to the weld, causing a bead to form on the surface. A clean bead indicates a strong weld. The filler material has been distributed evenly across the width and length of the weld. Oxyfuel outfits in modern industry are often used to cut or burn steel and other metals. You should be familiar with basic cutting operations and equipment. An oxyfuel cutting torch is similar to a regular oxyfuel torch, except that it has an additional tube to carry oxygen to the point of ignition. An oxyfuel cutting attachment converts a regular torch into a cutting torch. On both tools, the lever controls the flow of additional oxygen to the work. A well-made cut in metal has clean edges and minimal slag or waste metal. The cut is called a kerf. The correct position for cutting freehand in metal is a two-hand grip. Slide the torch along with one hand while stabilizing it with the other. The tip should be held at a 15 to 20 degree angle. When the metal is preheated to approximately 1500 degrees, it will appear bright red or orange. Then apply the cutting lever. The oxygen flow will produce a clean, even cut. This is an example of a clean cut made in steel plate with an oxyfuel cutting outfit. The quality of cuts you make will depend on your ability and your understanding of the methods and practices of modern welding. With that ability, many career opportunities await you in manufacturing, industry, and construction where modern welding skills are essential.